Good morning, everybody, and thank you so much for this generous introduction. I'm very, very happy to be here. I think this is a great opportunity for us to reflect on what is happening in our world today. Our lives are being impacted by the accelerated progress of technology and science. But let's not get confused. The future is defined by the decisions that we make today. And I'm going to be talking about many of the things that we need to be thinking about as we want to definitely define a future that is going to be looking better for us, for our society, and for our humankind as a whole. So the best way to project the future is to look at what happened in the past. Every technological shift, every technological wave completely changed the application landscape. From the PCs, to the internet, to the cloud, to mobile, the way that we interact with technology has profoundly changed over these technological shifts. Now, I would argue that artificial intelligence is not just a shift. It is a lift, it's a rift, it's a cliff-hanging moment, everything at the same time. And why am I saying that? Let's get an example, the smartphone, one of the most revolutionary technologies that was introduced in our lifetimes. The iPhone came to the world in 2007. It took 10 years to have 2 million apps in the App Store. We are now projecting that by 2028, there will be 1 billion new applications in the world, just 3 years from now. Those applications are coming to the world with the help of AI, many of them in the form of agents. And while that is going to bring tremendous opportunity and growth, the history shows that this also introduces complexity. And enterprises, organizations need to think about how they're going to address that going forward. I normally call this approach to IT strategy as a platform-centric approach. As I talk to many clients around the world, all of them bring the same concern. How do I demonstrate the return on investment on AI? When we go deep in those conversations, the first thing that comes up is that maybe you are not defining the right problems to be solved. Maybe you're not picking the right use cases. So everything starts really with how you want to apply the technology. Then you need to provide great user experience. You're going to have a combination of agents, assistants. All of them will have to be orchestrated and operating according to the guidelines of your organization, your ethical standards, your values. Then how about the data? The data that is going to be used by these applications. Data that is structured, meaning that data that is sitting in your ERP systems, in your core banking systems, or the unstructured data. That data that comes from logs of conversations you have with your clients, with your users, etc. Finally, because data today sits in so many different environments, the public cloud, a third-party application on the SaaS, a private cloud, at the edge, you have to have an architecture that allows you to integrate these multiple sources of data in a way that is comprehensive, in a way that is effective. And why is that important? While we experience AI through assistants and agents, it is really data that brings differentiation and competitive advantage. It is your data. The data that you have accumulated over the years, getting knowledge about processes, your clients, your products. Once you have that element in order, then you need to think about, okay, what model am I going to use to train that data? And the decision on your foundational model can make or break your AI implementation due to performance, due to localization, due to costs. There was a lot of talk about regulation, so governance becomes a very key element as you design those systems, but not just to address the regulatory requirements. Most importantly, to ensure that you're considering the risks associated with the technology, that you're not facing potential reputational impacts. So all those things, they have a business sense, not just addressing policies and requirements from agencies. Finally, you have to orchestrate all these different capabilities so that you can have visibility of how the systems are operating in your environment. I talked a lot about data, and I think that's the main reason why we have been discussing about sovereignty so much lately when it comes to AI. All the large language models that are out there, they have been mostly trained on publicly available data. So our estimation is that 99% of the data that today is sitting in the computers, in the environments, systems of organizations has not been touched by AI yet. Now, we have all been told that AI can generate approximately $4 trillion of productivity gains in the economy per year once it's been used in full capacity. Well, that economic impact is only going to be possible when AI is touching that data. And your AI is only as good as the data that you use to train it. I talked about models. Many companies, when they have to feed models with their data, are asking the question, what is the right model for me to consider? This is the topic of fit-for-purpose models. Many of them are open in nature because you have transparency on how they operate. They tend to be smaller, less than 13 billion parameters, because you can eventually host that model in your own servers, in your own environment. And they tend to be very cost-effective to run. In our benchmarks, our foundation models, Sirius, Granite, they represent 42 times lower cost of inferencing than working with larger models. So this topic of small language models, I think is becoming more and more of a trend, and that's probably the direction where AI is going to take when we're talking about enterprise AI. Now, AI has evolved very fast. A couple of years ago, we were all talking about training AI. Then we started to interact with chatbots, assistants in question and answering applications. And we are now starting the era of agentic AI. Agents are autonomous systems. They perform tasks, they make decisions to achieve certain goals, and they learn in this process. So the next time that they're going to execute a task, they'll try to do it in a better way. So they are dynamic. The introduction of agents in our economy is going to be a game changer. We believe that this is what is really going to drive economic impact through artificial intelligence. And at IBM, we are already experiencing that economic impact. Over 2022 and 2024, the application of automation, artificial intelligence, agents, all that enabled by our hybrid cloud capabilities, have generated $3.5 billion of productivity gains. We have applied this to multiple use cases. The most famous one is what we have been doing with our HR department. We implemented an agent called Ask HR, where we automated more than 80 common processes around the world. That agent today handles 94% of the inquiries that come to the HR department, while at the same time improving the satisfaction of our employees with the HR function and allowing our HR colleagues to focus on more strategic tasks, like talent strategy, helping our managers to be better managers for our employees, et cetera, and et cetera. Now, while I enjoy a lot talking about how we are using AI at IBM, it's what we are doing with our clients that give me most satisfaction. For example, what we have done with Accenture to develop an agent to support the organization of the Killer Book, which is a competition, a sailing competition, where they're having much better information to enjoy and to appreciate what is going on in a very chaotic week, because there are many competitions happening at the same time, so that they can have real-time information about the event. With Deutsche Telekom, one of the key activities when it comes to IT operations is to ensure that your software is up to date. Most of the cybersecurity incidents are caused by software that hasn't been patched, that hasn't been updated. Deutsche Telekom is applying automation to reduce the time that it takes to perform that task from days to hours. And that's pretty significant. Finally, we have been working to implement the hyperscaler Quant with the sovereign capabilities in Switzerland, so that they can develop AI applications for the country in a way that is addressing their sovereignty requirements. Now, this is everything that is happening with AI, moving fast. We are already experiencing the impact, but there is another technology looming on the horizon, and that's quantum computing. And according to BCG, we expect $500 billion of productivity gains from this technology when it is at scale. For IBM, since its inception, it's already a $1 billion business. So this is not just about research anymore. This is really starting to generate results for us. We have deployed more than 75 quantum computers around the world. One of them is here in Germany, in our data center close to Enningen. And one of the key reasons why we decided to have this data center here is because of what has been discussed in the previous two presentations here, the talent that we have in the country. Many of our quantum patents are coming from the development labs that we have here in Germany. So it's not just about the location, the physical location, but the ecosystem that you can develop around it. We're not only focusing on the hardware, we are also focusing on the capabilities, developing an environment so that developers can create their algorithms on quantum. That is our application, our language coding solution called Qiskit, that has been the most downloaded open source application development platform for quantum. And finally, we are already thinking about how we are going to integrate quantum computers with high-performance computing in a partnership that we announced with AMD a couple of weeks ago. Quantum is not going to be a substitution of classical computing. Quantum is going to be working in conjunction with classical computers to solve some of the most complex problems that we have in the world. We have been extremely consistent in our approach for quantum development. And we have always been careful to avoid making promises that we could not fulfill. So our objective is that by 2023, we could demonstrate quantum utility, which we did. By the end of next year, our goal is to demonstrate quantum advantage, meaning quantum that can solve problems in a more efficient and effective way that classical computers do. And by the end of this decade, we expect to have fully fault-tolerant quantum computers. This is when quantum computers can become really commercially available, because we start to address one of the major constraints to apply quantum, which is the amount of errors that are propagated when I'm using many, many qubits in one single machine. So that's the direction that we're going. Hopefully, by the end of this decade, we are going to have quantum computer commercially available in the world. And what are the types of problems that we are discussing with companies? We do have a network of partners, about 250 companies around the world, where we have been talking about, okay, what are the types of problems that quantum computing can be useful for? We have been working with the banking industry in risk management, addressing potential fraud situations, understanding clients better to provide better client experience. This is what we have been working, for example, with Crédit Mutuel in France. Here, with E.ON, we are looking at ways to make the network of energy better effectively distributed. And this topic of optimization is probably one of the best applications for quantum. With Bosch, we are looking at material science, finding probably new solutions to batteries to make them more effective, less pollutant, looking at other materials that can make it easier to produce batteries. And finally, we are working with Hartree in the UK in the area of clinical trials, how to look at molecules that can help, for example, patients recover from surgeries faster to reduce the amount of time that people will stay within hospitals. So lots of interesting problems, tremendous opportunity opening up in quantum. I think over the past few months, we saw a lot of activity in the field. And I think the reason for that is because we are really at that point where quantum advantage is actually going to be an engineering problem. We understand all the aspects that need to be addressed in order to make quantum available. So to conclude, with great powers come great responsibilities. This is not just about a technological shift. There is a tremendous impact in our society, and as leaders, it is our obligation, it is our duty to ensure that we are going to bring society along as part of this transformation. We are going to skill people, we are going to educate people, we are going to ensure that everybody gets a benefit, and that this doesn't become a technology that provides benefit just to a few. It's about progress, it's about bringing a better world for us. As I said in the beginning, it is the decisions that we take today that will define how future is going to look like for us. Thank you very much.